Hello lovelies, in this video we're going to be looking at the equation y equals mx plus c where we have two variables. There is an easier version in this video where there is only one variable. Now, the brilliant Mr. B is going to be working you through 15 different examples at 3 different levels, and you can jump into this wherever you feel most comfortable, trying the questions together as we go along.
Have a look at plotting lines. Now these will be even more complicated lines than in the last video, but we can use some of the same methods. So looking at question 1, we have y is equal to 2 lots of x plus 6. Now what we want to do is we want to find the value of about 3 coordinates. So we're going to need an x coordinate and we're going to need a y coordinate. Now, for the x coordinates, just pick any numbers you like, anything that's going to make it easy to solve this. So why not choose 1, 2, and 3? Then we want to work out what the y coordinate is. Now, y is equal to 2 lots of x plus 6. So we're going to find out what that is. So when x is 1, we're just going to substitute. We've got 2 lots of x, so we're going to swap the x for a 1. Remember that in algebra, we've got numbers and letters next to each other to be multiplied, and then we're going to add on 6 at the end. So we calculate that. 2 times 1 is 2, and 2 plus 6 is 8. And that is our y coordinate. Then we're going to do the same thing. We've got 2 lots of x, this time staying the x. So 2 lots of 2, and we're going to add on the 6. So 2 times 2 is 4, plus 6 is 10. The y coordinate x is 2, y is 10. Then we're going to repeat this, but this time we've got the 2, we've got the plus 6. We're going to find everything is all together, but x is going to be 3 this time. So we just see all I've done each time is change the value of the x for 1, 2, and 3. We can work that out. 2 times 3 is 6, and 6 plus 6 is 12. Now, I want to plot this on a graph, and my graph has got a y-axis and an x-axis, and they only go up to 10. So 12 is a little bit too big for this. So I'm going to try a smaller number, because I want to get 3 coordinates here. If I only have 2 and I made a mistake, I've got no way of knowing. But I've got 3 coordinates and I make a mistake, the line will not be straight anymore. Let's try 0. So we're going to have 2 lots of 0. Plus 6. Again, all I've done is swap the x with a 0. So 2 lots of 0 is 0, and add 6 gives us 6. So now I've got 3 coordinates that I can plot. We've got when x is 1, y is 8. When x is 2, y is 10. And we have when x is 0, y is 6. Again, we did have 3 and 12 as well, but that won't fit on our graph. So let's plot the 3 coordinates. So starting right in the middle, 1, 8 will be 1 to the right and 8 up. Let's plot it. 2, 10 would be 2 to the right and 10 up. Let's plot that. And then 0, 6 would be 0 across and then 6 up. And 3 coordinates that you plot should make a straight line. And then all you need to do is join up the line, and there's your answer. Label it as well. So we want to label that this is y is equal to 2x plus 6. Moving on to question 2, we're going to repeat the same method. So we have y is equal to 2 lots of x. Take away 6 this time. So what we're going to do is choose some values for x, so the smallest number as possible. So why not choose 1, 2, and 3. So we want to find out what y is. Y is 2 lots of x minus 6. So all we're going to do is set up the same equation, but we'll swap the x with 1. So 2 times 1 take away 6. And we can work that out. 2 times 1 is 2. 2 take away 6 is negative 4. Then we're going to do the same thing, but this time we're going to swap the x with a 2. So it would read 2 times 2 take away 6. 2 times 2 is 4. And 4 take away 6 is negative 2. And then we'll do it one more time. We want to get 3 coordinates. We've got the times 2, take away 6 stay the same. The x is changing for the 3. So 2 times 3 is 6, and 6 take away 6 is 0. This gives us 3 coordinates we can use. A negative 4, we have 2, and negative 2, and we have 3 and 0. So we're going to plot those 3 coordinates onto our graph. So 1, -4 will be 1 to the right and 4 down. 2, -2 will be 2 to the right and 2 down. And start in the centre, 3, 0 will be 3 to the right and then 0 down. We can see that we've got a straight line, so now we can join it up. And then label your answer at the end. So that was y is equal to 2x minus 6. Just draw a little arrow to show which one it's pointing to. And that's our answer. Now, before we move on, there's two important things to notice. Both of these lines have a 2x, and 2 is what we call the gradient. So if we go one space to the right from either line, you'd have to go 2 spaces up to get back to the line. 1 across and 2 up. And on the other line, let's see the same thing works. If we go 1 across from the line, then we would have to go 2 upwards to get back to the line. So they've both got the same steepness, and we can see they're both parallel to each other. The other thing to notice is where they cross the y-axis. Y equals 2x plus 6 crosses the y-axis at 6, and y equals 2 minus 6 crosses the y-axis at -6. So we can use the information in the equation to know things about what the line should look like. This will be important later on when I show you a faster method. Is equal to x minus 4. Again, we'll choose some values for x. 1, 2, and 3 should do fine. And then we want to find out what y is, which is 3 lots of x minus 4. So each time we're going to be multiplying by 3. Each time we're going to be taking away 4. But we're going to swap the x with 1, 2, or 3. So times 1, times 2, and times 3. Remembering when a number and letter are next to each other in algebra, they are going to be multiplied. So let's work out what y is in each case. 3 times 1 is 3. Take away 4 is -1. 3 times 2 is 6. Take away 4 is 2. And 3 times 3 is 9. Take away 4 is 5. This gives us 3 coordinates, x value and the matching y value. So 1 and -1, 2 and 2, 3 with 5. So let's plot these on the graph and see if they line up. So 1 to the right and 1 down. 2 to the right, 2 up. And 3 to the right and 5 up. We're going to join them up with a ruler, and they should be making a straight line if we've done this correctly. So we can see they do make a straight line, so we've definitely got the right answer. And we're going to label the line. So we'll label this one at the bottom. So we've got y is equal to 3x minus 4. Do a little arrow to show which of those two lines it actually is I'm referring to. Now, again, before we move on, there's two important things to notice. It's y equals 3x, so at any point in the line, you go 1 across. You're going to have to go 3 up to go back to the line, so that's where that 3 comes from. With the -4, you'll see that it crosses the y-axis at -4. In the algebra equation, can be seen on the graph. And this is going to be important now for question 4 and 5. We're going to do these questions without the table. So for question 4, we have y is equal to 4x plus 2. And there's two important things we need to talk about. Firstly, we have the 4 on the 4x, and then we have the plus 2 at the end. And both of these things have got special names. So firstly, the 4 is what we call the gradient. Now, there is an algebra letter reserved for gradient, and we usually use an m to show gradient. Then the plus 2, we call that the y-intercept. It's where it crosses the y-axis. And there's an algebra letter reserved for that as well, and we call that c. So we've got the gradient, and we've got the y-intercept. There's a common form to write down what these equations are, and it's y is equal to mx plus c. And you can see the y equals 4x plus 2, follows the same pattern. The m has been swapped with a 4, so we'll have a gradient of 4, and the c has been swapped with a 2, so we'll have a y-intercept of 2. Now, first, we're going to talk about the gradient. Now, the gradient is going to have a steepness of 4, which should look like the line I've just drawn over to the side. Now, with the gradient, the way it's going to look like on the graph is that at any point, it's going to form a triangle, and it's going to be one space across at the bottom, and then the triangle going upwards is going to be 4 spaces going up. And that's going to form a gradient of 4 because you can see we've got a 4 in a triangle shape there. The second thing to look for is the plus c set, and so we know that our line is going to cross by 2 on the y-axis. So I've just drawn a little dot where 2 on the y-axis is. Our line needs to go through that point. It needs to intercept, cross over the y-axis at that point. So what we can do to draw our line is draw our little triangle at the side of it. So we can go 1 space across, we can go 4 spaces upwards, and that's going to give us another coordinate on the line. And we join those 2 coordinates up, we're going to get our triangle, and it's going to be at the correct gradient. Now, we always want 3 coordinates just in case we made any mistakes. So all we need to do is do the same thing again. So we're going to go 1 across, we're going to go 4 up, and that's going to form another coordinate on the line. And then we can join up all 3 coordinates. Last thing to do is label it. So we just found y is equal to 4x plus 2. Now, I ran out of space to label this properly, so I had to rub out the previous questions. So if this happens, say, in an exam or a piece of homework, just draw a completely brand new graph and everything should be fine. So now we're going to move on to question 5. So we're going to change the equation we're working with. So it's now going to be y is equal to 5x minus 9. We're going to identify the gradient and the intercept, and you can see that y equals 5x plus a y equals mx plus c format. We've just swapped the m for a 5, so that's the gradient. That's how steep our line's going to be. And we've swapped the plus c with a minus 9. So that's going to be where we cross the y-axis. So we can label that on the graph straight away. Negative 9 on the y-axis is where I'm highlighting on the graph now, right at the bottom. So that's the intercept dealt with. Our line has to go through that point. Now, for the gradient, it's going to have a steepness of 5, so it's going to be a line, like I've just drawn at the side. And for the gradient, if you go 1 space to the right, then you're going to have to go 5 spaces upwards to get back to the line. And it's going to form a triangle like that with a height of 5. So going over to the graph, we can go 5 up, 1, 2, 3, 4, 5, and that's where our next coordinate is going to be. But we want to do this 3 times with 3 coordinates. We've only got 2, so let's do it one more time. So 1 across, 1, 2, 3, 4, 5 up. And now we've got 3 coordinates, and we can join up those 3 coordinates to create our line. So draw the part going downwards first, and then the part going upwards. Last thing to do is label it. Y is equal to 5x minus 9. I'm just going to make it clear at the end which line each label is pointing to. So if you do this in the exam, make it extra clear to the examiner which line is which. Moving on to the medium questions, we'll follow the same method. We'll do 3 using substitution, then we'll do 2 looking at the gradient and the intercept. So firstly, we're having a look at y is equal to negative 2x. So now we have negative numbers and minus 6. So we're going to draw a table. We're going to choose some values for x. So we can usually start off with 1, 2, and 3, just the easiest numbers. And then y is going to be negative 2x minus 6. So we're going to try and work that out. And the way we're going to do it is swap x with each number 1 at a time. So to start off, I have negative 2 times 1, so swapping the x with a 1, and then take away 6, and we can work this out. So negative 2 times 1 would be negative 2, and negative 2 take away 6 would be negative 8. Doing that now for part 2, so we have our negative 2, swapping x with a 2, and then we're taking away 6. So negative 2 times 2 is negative 4. Now we can do it with 3, so negative 2 times 3. So negative 2 times 3 is negative 6. Take away another 6 would give us negative 12. Now, our graph only goes up to 10. 12 won't fit on. So we need to choose a smaller number because 3 isn't going to work. So let's choose 0. So we do negative 2 times it by 0. Anything times 0 is going to give you 0. Then we're going to take away 6, which will give us negative 6. This gives us 3 coordinates we can work with. So the 1 goes with negative 8. The 2 goes with negative 10. And the 0 goes with negative 6. So plot all 3 onto the graph. So 1, negative 8, we want to write an 8 down. Would be 2 to the right and 10 down. And 0, negative 6 would be 0 across and then 6 down. All 3 coordinates should be making a straight line. And if you make a straight line, then draw a line all the way through. Finally, label your answer. So we have found negative 2x, take away 6. You might notice the difference between this question and the easy questions is a line is pointing in the opposite direction. From left to right, the line is going downwards. Whereas the easy question, from left to right, the line was going upwards. Now, moving on to question 2, we have y equals negative 2x, take away 5. And that's very similar to our previous question. It's going to reuse a lot of the working out. So the 6 has turned into a 5. So we are taking away 5 each time. But the minus 2x section is going to be exactly the same. So let's work this out. So negative 2 times 1 is negative 2. Take away another 5 will give us negative 7. Negative 2 times 2 is negative 4. Take away another 5 is negative 9. Negative 2 times 3 is negative 6. Take would be negative 11, which is too large for a graph, so I'll have to do one more. Negative 2 times 0 would be 0. Take away the 5, give us negative 5. Again, we've got 3 coordinates we can work with. 1 is going with negative 7. 2 goes with negative 9. And 0 goes with negative 5. So let's plot these on the graph. So 1 to the right and 7 down. Then we'd have 2 to the right and 9 down. And then we're going to have 0 across and then 5 down. And again, we can see these form a straight line. So let's join them up. Then label that the second line is y equals negative 2x minus another 5. Now you can see the 2 questions we've done here, question 1 and question 2, are very, very close together. They are both negative 2x, so we can see the lines are parallel, and negative 5 is across the y-axis at negative 5. So because those y-intercepts are so close, are they parallel, that explains why these 2 lines are so close together. Moving on to question 3, we have y equals negative 3x plus 2. So we're going to replace the x in negative 3x with 1, 2, and 3. So we can plot this on the graph. So each time we're multiplying by negative 3. Each time we're adding 2 on at the end. And getting an answer. The x with a 1, a 2, and a 3. So let's work this out. Negative 3 times 1 is negative 3, plus 2 will give us negative 1. Negative 3 times 2 is negative 6, plus the 2 is negative 4, and negative 3 times 3 is negative 9, plus the 2 is negative 7. That gives us 3 coordinates we can plot. The 1 goes with negative 1, the 2 goes with negative 4, and the 3 goes with negative 7. So let's plot them, 1 across and and 1 down, 2 across and 4 down, and 3 across and 7 down. Looks like they make a straight line, so let's plot it. And then we're going to label our answer. So we have y is equal to negative 3x plus 2. Now let's try the other method for question 4 and 5. So every single one of these lines holds the format y is equal to mx plus c. We're looking at y equals negative 4x, so the gradient is negative 4, and then plus 8, so the y-intercept is at 8. The first thing we can do is we can go to 8, and we know that our line, no matter what, has to go through 8 at that point. Then with our gradient, this time it's going to be pointing the other direction, but it's going to follow the same rules. So if you go one space across, this time to the right, therefore you're going to have to go 4 to get back up to the line. So what we can do from the 8 that we've identified on the graph is go 1 across. Now we can't go 4 up because that'll run off the graph, but we could go 4 down. So I'm going to go 4 downwards and 1 across, and I can draw our next coordinate. And if we join that up, we get that exact same triangle we've got written off at the side. I want 3 coordinates to make sure I don't make any mistakes. So again, I'm going to go 4 places down, 1 across, and when I join it up, it's going to form the triangle. They all seem to be in the same place, so now we can join them up. And then once you join them up, just continue to the end of the page. Last thing we need to do is label the line. And if you're in a space like I have, then just draw a brand new graph. But this one was y is equal to negative 4x plus 8. Now moving on to the last question, we have a negative 5 for the gradient, and we have a negative 4 for the y-intercept. It's y equals negative 5x minus 4. Straight away, we know that this has to go through negative 4 on the y-axis, because that's the y-intercept. So for the gradient, we're going to have a gradient of negative 5. So in the same direction of all the rest of the lines, it's going to look like that off to the side. And if we go 1 space over to the right, then to get back to the line, because it's a 5, we're going to have to go 5 spaces back up. So just follow that pattern on the graph. So 1 to the right, left, and 5 up. And this will give us our new coordinate. And then do it one more time to make sure we've got 3 coordinates. So 1 space to the side and 5 upwards. If they make a straight line, you're good to go, and you can join them all up. And then once we've done that, we just need to label our answer. So we found y is equal to negative 5x take away 4. Looking at the hard questions, now again, we can see these all follow the format. Y is equal to mx, with m being the gradient, and then a plus c with the number at the end being where we go through the y-axis. Now, we could do all of these using substitution method, and that would work just fine. Might have a bit of a problem with the decimal numbers, and if it's a half, you don't want to stick to the 2 times table for x. If it's the third, the 3 times table for x, and the fourths, the 4 times table for x. But I'm thinking about kind of thinking ahead and thinking about what numbers I need to be using. Just make it a little bit harder. So I'm just going to use the gradient and intercept method for all of these. Now, firstly, I'm going to talk about the gradient, m, and we're just going to have a look at what various gradients look like. So a gradient of 1 half, it's going to have a look, it's going to look like this, where if you go to the left, then you are having a distance of 2, and then it'll be a distance of 1 to get back up to the line. So that kind of triangle shape is going to give you a gradient of a half. So I can write that m be equal to 1 over 2. I've done the y movement, the up and down movement, divided by the x movement, the side to side movement. Now, with a negative half gradient, it would be the other way around. So when we go 2 across, it would be in the other direction. The line is going downwards, left to right rather than upwards, but it would still be 1 to get back up to the line. So the gradient would be negative 1 half. Because that 2, it's moving in the negative direct axis. A gradient of a third would work the same way. This time you'd be moving 3 across and 1 to get back up to the line. So the gradient would be the y distance 1 divided by the x distance 3. Same thing for m is equal to a negative third. It's just going to be a line pointing the other direction. So your x movement is going to be backwards. It will still be 3 across and 1 up. So 1 over 3. We've got the gradient being a quarter, and again, exactly the same thing, where you're going 4 spaces to the right, and then 1 space upwards. A gradient of negative a quarter would be the same, only the line is going to be facing the other direction. So 4 across, a gradient angle shaped, and making sure that your gradient is always going to be the y value divided by the x value. And if the division on a triangle gives you the fraction you're looking for, then you know you've got the right one. Now, I can't fit labels for all 5 graphs onto the line, so what I'm going to do is colour code this. So for y is equal to a half x minus 4, I'm going to do that line in blue. Y minus 9, I'm going to do in green. The next one I'm going to do in purple. Question 4 in a different shade of purple. And then question 5 I'm going to do in pink. Just so you can see clearly which line is which. On an exam paper, you should have room to write all the labels that you need. You probably won't have more than 2 lines on one graph. Alternatively, you could label them with letters. So with question 1, there is a minus 4 on the end. So I know that line is going to have to go through negative 4 on the y-axis. That's the y-intercept. The gradient is half, so I look over to the key at the sides, and I know that each time we're going to be going 2 across and 1 up for the next coordinate. I'll do it one more time, 2 across and 1 up for our next coordinate. And we can see that all of those are in a line, so now we can plot the line. We can do the same thing with question 2, so we can see we've got a minus 9 on the end, definitely going to be going through negative 9 on the y-axis. The gradient is a third, so we're going to be going 3 across and 1 up to our next coordinate. And again, 3 across and 1 up coordinate. Once we've done that, if it's a straight line, we can join them all up. Now moving on to question 3. So we have a minus 3 at the end, so we know our line is definitely going through negative 3 on the y-axis. The gradient is a negative third, so it's going to be 3 towards the negative side of the axis and then 1 up for our next coordinate. And again, 3 over to the left and 1 up. If it's going down, then it's a negative gradient, and if it's going up, then it's a positive gradient. Now looking at question 4, so this also has an intercept of negative 3. So we're going through the same place as the last question, but it's got a different gradient. It's a positive quarter. So we need to go 4 towards the positive side of the x-axis and 1 up for our next coordinate. And again, 4 towards the positive side of the x-axis for our next coordinate. Now moving on to our final question. So we can see we've got a +1, so it's going through 1 on the y-axis, and the gradient is a negative quarter. So the bottom number of your fraction is how far across we're going. So it's a negative side for a negative number, and the top number of your fraction, the numerator, is how far up we are going to our next coordinate. So denominator of 4, move across 4, numerator of 1, move up 1. Straight line, and it's a negative line, so it's going from left to right, it's going downwards. Let's join it up. And there we have our final answer. So you've been shown two methods here. So if you're not very confident with your graphs, then just substitute like I showed you on the first three questions. But if you're feeling more confident and you want to move a little bit more quickly, then you can look at the gradient and the intercepts and do it that way. And that's going to help you do these much more quickly and be able to check your answers as well and get a good idea of what your answers should be looking like.
Ouch! This is why in some videos I have unexplained scratches.